July 10, 1942, Akutan Island, Alaska Territory. The wind howled across the North Pacific, cutting through layers of fog like a living thing. Inside the cockpit of a U.S. Navy PBY Catalina machinist's mate, Albert Knack, steadied his binoculars. Through the murky glass, he glimpsed something impossible, a flash of red, the circular insignia of Japan's rising sun. Below, half buried in marshland, lay a Japanese Zero fighter inverted wings, outstretched almost perfectly intact. Lieutenant William Teese, the patrol pilot, circled the site 3 times, marking its position on his chart. Neither man could have known that this accidental sighting, born of fog fatigue and chance, would alter the trajectory of the Pacific War. The plane below them was no ordinary wreck. It was an intact Mitsubishi A6M0 serial number 4593, the Imperial Japanese Navy's deadliest weapon and one of the most feared fighters in aviation history. For more than a year, this sleek machine had ruled the Pacific skies with near supernatural superiority. American pilots whispered about it in ready rooms, how it turned tighter, climbed faster, and struck harder than anything they could put in the air. At Pearl Harbor, the Philippines, Malaya, and Burma Zeros had carved a trail of destruction, annihilating Allied aircraft by ratios that defied belief, sometimes 12-1. American commanders facing these losses issued humiliating orders to their pilots. Do not engage a Zero in a dogfight. Run, dive, and escape. For the Allies, the Zero seemed to defy physics itself. It was carrier-based, yet outperformed land-based interceptors. It carried long-range tanks that allowed it to fight across half the Pacific, yet maneuvered with the agility of a sport plane. To American engineers, this combination seemed impossible. How could Japan, a nation long dismissed as technologically inferior, produce a fighter that eclipsed every Western design? That question would soon be answered not in the laboratories of Tokyo or Washington, but in the silent marshes of Akutan. The story began a month earlier. June 4, 1942, the same day as the Battle of Midway. While U.S. carriers clashed with Japan's main fleet far to the south, a diversionary Japanese force struck the remote Aleutian Islands in the far north, hoping to split American attention. Among the pilots was 19-year-old Flight Petty Officer Tadayoshi Koga, flying from the carrier Ryujo as part of a 3-plane unit assigned to attack Dutch Harbor, Alaska. Koga's aircraft Zero serial number 4593 was formidable, even by Japanese standards. Sleek silver gray, armed with twin 20mm cannons and 7.7mm machine guns, it represented the cutting edge of Japanese naval aviation. That morning, Koga and his wingmen dove through thick cloud toward the American outpost. They strafed a PBY Catalina flying boat, killing crewmen in the water below. But during the attack, a lucky burst of small arms fire from the ground found its mark. A bullet severed the oil line of Koga's Nakajima Sakai engine. The damage was not immediately fatal, but it sealed his fate. Oil pressure dropped. Smoke streamed from the cowling. Koga signaled his wingmen and turned toward Akutan Island, a designated emergency landing site where a Japanese submarine waited offshore to recover downed pilots. Below him, the island appeared calm, a grassy plateau just beyond the shoreline, flat and inviting. From altitude, it looked like salvation. His wingmen, Chief Petty Officer Makoto Endo and Petty Officer Tsuguo Shikata, circled above, watching helplessly as Koga descended. They saw the wheels touch the grass, and then horror. The landing gear sank instantly into hidden marshland. The plane pitched forward, flipping end over end before slamming upside down. The propeller shattered, the canopy crushed. Inside, Koga was killed instantly, his neck broken by the impact. Endo and Shikata faced an impossible choice. Every Japanese pilot carried orders to destroy any Zero that crash-landed in enemy territory. Its secret's engine armament materials were too valuable to risk capture. But Koga was their comrade. He might still be alive. Neither man could bring himself to strafe the wreck. Low on fuel, they turned away, trusting the submarine below to retrieve him. But the sub never found Akutan. Driven off by the American destroyer USS Williamson, it abandoned the search. For weeks, the wreck lay hidden in the fog, a lost secret of the Pacific, buried in mud and silence. Then, on that fateful July morning, Lieutenant Tease stumbled upon it. When a recovery team returned the next day, they found the Zero remarkably intact. The body of Tadayoshi Koga still hung inverted in the cockpit. The Americans removed him gently and buried him nearby with full military honors, a gesture of respect from one warrior to another. Then they turned to the aircraft itself, studying it with awe and disbelief. The first discovery stunned them. The Zero had no armor protection at all. No steel behind the pilot's seat, no bulletproof glass, no self-sealing fuel tanks. Its metal skin, when tapped, sounded thin, almost hollow like a tin can. To American eyes accustomed to heavy, overbuilt warplanes like the Grumman Wildcat, it seemed suicidal. Yet somehow this fragile machine had been winning. Aviation pilot William Tease later wrote that touching the Zero felt like handling something alive. Every surface had been designed for agility, every ounce of weight shaved away with surgical precision. It was, as one mechanic described, the perfection of risk. The team documented everything: measurements, materials, construction joints, control surfaces. They found that even with damage, 6 men could move the aircraft by hand across the marsh. Its lightness defied logic, but it also held the key to Japan's early victories. For the U.S. Navy, this find was priceless. They had captured not a wreck, but a working blueprint of Japan's air supremacy. Inside its frame lay answers to the Pacific's most urgent question: what made the Zero unbeatable? By July 15th, after several failed attempts due to the Aleutian storms, the Americans finally hauled the plane to the coast using a makeshift sled. From there, it was loaded onto a barge and shipped to Seattle, then to San Diego's Naval Air Station, North Island, for restoration. It would take more than a month to reach California, but that month would soon reshape air combat across the Pacific. What the Americans would uncover next was not just a machine's secret, but a philosophy, a radical difference in how two nations viewed life, death, and the art of war. August 1942. Naval Air Station, North Island, San Diego. The hangar doors slid open with a metallic groan as sunlight spilled across the strange new arrival from Alaska. Mechanics, pilots, and intelligence officers gathered around the inverted silhouette, resting on a flatbed truck. For the first time, American engineers were looking not at a rumor, but at the enemy's crown jewel, the Mitsubishi A6M-0, code-named Zeke. Guards posted around the hangar had strict orders: no unauthorized entry, no souvenirs, and shoot to stop any attempt to remove a piece of the aircraft. The Navy understood the magnitude of what they possessed. In their hands lay the key to defeating an enemy that had until now ruled the Pacific with effortless dominance. Lieutenant Commander Eddie Sanders, a test pilot with nerves of steel and a methodical mind, was chosen to oversee the Zero's resurrection. The recovery team began by documenting every detail, measuring wing curvature, examining rivet spacing, and weighing every component. What they found astonished them. The Zero was not a crude imitation of Western engineering as propaganda had led many to believe. It was a masterpiece of efficiency. Every component existed solely for performance. Nothing was wasted, not a gram, not a bolt. Even its fragility was a form of purpose. The wing spars were made of extra super duralumin, a specialized aluminum alloy developed by Japan's Sumitomo Metal Industries in the mid-1930s. Stronger than standard aircraft aluminum, It offered high tensile strength at half the density, but it corroded easily. The Japanese had solved this by coating each part with zinc chromate, a detail that impressed even American metallurgists. To save weight, the engineers at Mitsubishi had eliminated removable joints entirely. The wings were permanently bonded to the fuselage, creating a seamless aerodynamic surface that reduced drag and maintenance complexity. Control surfaces like the ailerons and rudder were covered in fabric rather than metal, an anachronism in 1940s aviation, yet one that contributed to extraordinary handling at low speeds. Even the cockpit was minimalist. No armor behind the pilot's seat, no steel reinforcement, no bullet-resistant glass. The seat itself was little more than a thin aluminum frame with a fabric cushion. Sanders ran his hand across the instrument panel. Simple, functional, elegant. It was as if every ounce of weight had been sacrificed to the gods of maneuverability. Then came the revelation that shocked the Navy's flight engineers, the Zero's fuel system. Instead of self-sealing tanks, the standard in American aircraft, the Zero used thin aluminum containers without protection. They could hold more fuel and keep weight down, but a single bullet through the tank meant instant fire. The Americans realized the brutal logic Japan had designed its fighter for pilots who were expected to die. The Zero was not built to bring men home. It was built to win now, fast and decisively. Eddie Sanders called it a brilliant aircraft with a fatal philosophy, while the repair crews worked intelligence officers debated the implications. In just 7 months, this plane had destroyed hundreds of Allied aircraft across the Pacific. Yet it had done so not because it was indestructible, but because it exploited the psychology of its opponents. Allied pilots, terrified by its agility, had allowed fear to dictate tactics. The Zero's legend was its greatest weapon. By early September, the aircraft was ready. Sanders climbed into the cockpit for its first test flight since the crash. The crowd watched silently as the radial engine, a Nakajima Sakai 12, sputtered to life, coughing smoke, before settling into a smooth, steady growl. It was smaller and lighter than the American Pratt & Whitney Twin Wasp, but deceptively efficient. The Zero taxied down the runway like a predator waking from hibernation. When Sanders advanced the throttle, the aircraft surged forward with an almost unnatural eagerness. At just 500 feet, it leapt into the air. Observers below noted how short the takeoff run was, barely half that of a Grumman Wildcat. At altitude, Sanders began testing the controls. His first impression was electric. The Zero handled like a feather. Where American fighters required muscle, this aircraft responded to the lightest touch. It banked gracefully, turned inside its own wingspan, and climbed with startling agility. But then came the hidden weakness. At speeds above 200 knots, the ailerons stiffened dramatically. Rolling the aircraft required immense force, especially to the right. Sanders realized that the Zero's unmatched agility only existed at low speeds. Above 250 mm, its controls froze, a fatal flaw in modern air combat where speed meant life. He dove the aircraft to test its limits. The engine screamed in suddenly silence. The engine had cut out completely. Sanders fought the controls, gliding for several seconds before the engine sputtered back to life. It had happened because the Zero's carburetor used a simple float mechanism that starved the engine of fuel under negative Gs, a design quirk common in pre-war aircraft. That discovery alone would save hundreds of Allied lives. It meant that if an American pilot was being chased by a Zero, all he needed to do was push the stick forward into a dive. The Zero's engine would die. The Americans would not. In those few seconds, he could escape. Sanders repeated the tests over 24 flights between September and October. Every time the same patterns emerged. Below 200 mph, the Zero was untouchable. Above 250, it became heavy and unresponsive. At negative Gs, it was helpless. By late October, a comprehensive report was distributed to every U.S. fighter squadron in the Pacific. It outlined for the first time the Zero's exact strengths and weaknesses, its roll limits, its stall speeds, its vulnerability in dives. Commanders built new tactics around this intelligence. The boom and zoom method, dive fire once and climb away, became standard doctrine. Pilots learned to avoid dogfights entirely, instead using vertical attacks and high-speed passes. What had been a nightmare became a puzzle one they could now solve. In less than 4 months, the Akutan Zero had transformed from a symbol of Allied despair into the foundation of Allied confidence. It was no longer the mythic ghost of the Pacific. It was just another machine extraordinary, but mortal. And in that realization lay the beginning of Japan's downfall. Because from this captured wreck, the Americans had learned not only how to defeat a fighter, but how to dismantle a legend. August 1942. Naval Air Station, North Island, San Diego. The hangar doors slid open with a metallic groan as sunlight spilled across the strange new arrival from Alaska. Mechanics, pilots, and intelligence officers gathered around the inverted silhouette resting on a flatbed truck. For the first time, American engineers were looking not at a rumor, but at the enemy's crown jewel, the Mitsubishi A6M0, code-named Zeke. Guards posted around the hangar had strict orders. No unauthorized entry, no souvenirs, and shoot to stop any attempt to remove a piece of the aircraft. The Navy understood the magnitude of what they possessed. In their hands lay the key to defeating an enemy that had until now ruled the Pacific with effortless dominance. Lieutenant Commander Eddie Sanders, a test pilot with nerves of steel and a methodical mind, was chosen to oversee the Zero's resurrection. The recovery team began by documenting every detail, measuring wing curvature, examining rivet spacing, and weighing every component. What they found astonished them. The Zero was not a crude imitation of Western engineering as propaganda had led many to believe. It was a masterpiece of efficiency. Every component existed solely for performance. Nothing was wasted, not a gram, not a bolt. Even its fragility was a form of purpose. The wing spars were made of extra super duralumin, a specialized aluminum alloy developed by Japan's Sumitomo Metal Industries in the mid-1930s. Stronger than standard aircraft aluminum, it offered high tensile strength at half the density, but it corroded easily. The Japanese had solved this by coating each part with zinc chromate, a detail that impressed even American metallurgists. To save weight, the engineers at Mitsubishi had eliminated removable joints entirely. The wings were permanently bonded to the fuselage, creating a seamless aerodynamic surface that reduced drag and maintenance complexity. Control surfaces like the ailerons and rudder were covered in fabric rather than metal, an anachronism in 1940s aviation, yet one that contributed to extraordinary handling at low speeds. Even the cockpit was minimalist. No armor behind the pilot's seat, no steel reinforcement, no bullet-resistant glass. The seat itself was little more than a thin aluminum frame with a fabric cushion. Sanders ran his hand across the instrument panel, simple, functional, elegant. It was as if every ounce of weight had been sacrificed to the gods of maneuverability. Then came the revelation that shocked the Navy's flight engineers: the Zero's fuel system. Instead of self-sealing tanks, the standard in American aircraft, the Zero used thin aluminum containers without protection. They could hold more fuel and keep weight down, but a single bullet through the tank meant instant fire. The Americans realized the brutal logic. Japan had designed its fighter for pilots who were expected to die. The Zero was not built to bring men home. It was built to win now, fast and decisively. Eddie Sanders called it a brilliant aircraft with a fatal philosophy, while the repair crews worked intelligence officers debated the implications. In just 7 months, this plane had destroyed hundreds of Allied aircraft across the Pacific. Yet it had done so not because it was indestructible, but because it exploited the psychology of its opponents. Allied pilots, terrified by its agility, had allowed fear to dictate tactics. The Zero's legend was its greatest weapon. By early September, the aircraft was ready. Sanders climbed into the cockpit for its first test flight since the crash. The crowd watched silently as the radial engine, a Nakajima Sakai 12, sputtered to life, coughing smoke, before settling into a smooth, steady growl. It was smaller and lighter than the American Pratt & Whitney Twin Wasp, but deceptively efficient. The Zero taxied down the runway like a predator waking from hibernation. When Sanders advanced the throttle, the aircraft surged forward with an almost unnatural eagerness. At just 500 feet, it leapt into the air. Observers below noted how short the takeoff run was, barely half that of a Grumman Wildcat. At altitude, Sanders began testing the controls. His first impression was electric. The Zero handled like a feather. Where American fighters required muscle, this aircraft responded to the lightest touch. It banked gracefully, turned inside its own wingspan, and climbed with startling agility. But then came the hidden weakness. At speeds above 200 knots, the ailerons stiffened dramatically. Rolling the aircraft required immense force, especially to the right. Sanders realized that the Zero's unmatched agility only existed at low speeds. Above 250 mph, its controls froze, a fatal flaw in modern air combat where speed meant life. He dove the aircraft to test its limits. The engine screamed, and suddenly silence. The engine had cut out completely. Sanders fought the controls, gliding for several seconds before the engine sputtered back to life. It had happened because the Zero's carburetor used a simple float mechanism that starved the engine of fuel under -Gs, a design quirk common in pre-war aircraft. That discovery alone would save hundreds of Allied lives. It meant that if an American pilot was being chased by a Zero, all he needed to do was push the stick forward into a dive. The Zero's engine would die. The Americans would not. In those few seconds, he could escape. Sanders repeated the tests over 24 flights between September and October. Every time the same patterns emerged. Below 200 mph, the Zero was untouchable. Above 250, it became heavy and unresponsive. At -Gs, it was helpless. By late October, a comprehensive report was distributed to every U.S. fighter squadron in the Pacific. It outlined for the first time the Zero's exact strengths and weaknesses, its roll limits, its stall speeds, its vulnerability in dives. Commanders built new tactics around this intelligence. The boom and zoom method, dive fire once and climb away, became standard doctrine. Pilots learned to avoid dogfights entirely, instead using vertical attacks and high-speed passes. What had been a nightmare became a puzzle one they could now solve. In less than 4 months, the Akutan Zero had transformed from a symbol of Allied despair into the foundation of Allied confidence. It was no longer the mythic ghost of the Pacific. It was just another machine, extraordinary, but mortal. And in that realization lay the beginning of Japan's downfall. Because from this captured wreck, the Americans had learned not only how to defeat a fighter, but how to dismantle a legend. By late October 1942, word of the Akutan Zero had spread through every American air base from Hawaii to Guadalcanal. What began as a random discovery on a fog-covered island was now reshaping the entire Pacific Air War. Flight instructors pinned copies of Lieutenant Commander Eddie Sanders's test reports on briefing room walls. The diagrams showed the Zero's roll limits, dive restrictions, and the exact speed where its control surfaces froze. To the pilots who had spent months running for their lives, the data felt like a miracle printed on paper. For the first time, the Allied flyers could look their enemy in the eye. The myth of invincibility was over. At North Island, Sanders continued pushing the Zero to its edge. In simulated dogfights against American fighters, Grumman Wildcats, P-40 Warhawks, and Lockheed P-38 Lightnings, the truth became clear. Below 200 miles per hour, the Japanese aircraft still danced like a leaf in the wind. But once the fight went vertical, or once speed rose above 250, the American machines dominated. The heavier Wildcats, previously scorned for sluggishness, suddenly showed their advantage. They could dive faster, take damage, and still climb back to fight another day. The contrast was philosophical as much as mechanical. The Japanese engineers had built their machine for perfection in a moment, a single decisive clash where one turn could mean victory. The Americans, as one RAND analyst would later write, had built theirs for endurance, the power to survive dozens of imperfect fights and return for the next. In that difference lay the DNA of two nations at war. The U.S. Navy began teaching every fighter squadron a new doctrine called energy, fighting a concept that used speed and altitude as weapons instead of agility. Pilots were drilled to remember three commands: don't turn, don't slow, don't stay. A pilot's goal was no longer to dogfight, but to strike and escape. Dive from above fire, one controlled burst, then use gravity and horsepower to zoom out of reach before the Zero could react. The faster F-4F Wildcats and later F-6F Hellcats turned this into an art. To test these new theories, Sanders flew the captured Zero against the best American pilots in mock combat. One of them, Commander John Thatch, the inventor of the famous Thatch weave, took particular interest. His defensive formation allowed two fighters to protect each other by crossing paths repeatedly, forcing any pursuer into the line of fire of its partner. When Thatch flew the captured Zero himself, he realized his tactic's full potential. The Zero's slow roll rate at high speed meant that it could not follow two weaving targets at once. The weave became doctrine overnight. The psychological change was immediate. For months, U.S. pilots had seen the Zero as a phantom, faster, higher, unbeatable. Now they saw it for what it was, a blade sharpened too thin. Once you understood it, one pilot later said, it wasn't a monster. It was just fragile. The intelligence gathered from the Akutan Zero went far beyond tactics. American engineers dissected its components like archaeologists uncovering a lost civilization. The deeper they looked, the more they understood how Japan's pre-war industry had achieved the impossible. The Zero's engine mounts were machined with almost artistic precision. Its control cables were hand-woven from high-tensile steel strands, thinner than a pencil lead. Everything reflected a culture that valued craftsmanship over replaceability. Yet this was also the Zero's Achilles heel. The very qualities that made it exceptional in 1941, lightweight alloys, meticulous hand assembly, made it impossible to mass produce at the scale the war now demanded. Japan's factories could turn out perhaps 100 Zeros a month. The U.S. could produce 500 Wildcats, 600 P-40s, and by 1943, nearly 800 Hellcats every month. Economic historians later described this as the industrial asymmetry of attrition. The United States, with its vast supply of aluminum oil and machine tools, could afford to trade weight for protection. Japan could not. Rand's post-war report, Lessons from the Pacific Theater, noted that Japanese planners assumed a short conflict lasting less than 2 years. Their aircraft design reflected that belief: maximize performance now, because there may not be a later. But there was a later. As American pilots trained with new tactics, Japan's supply of veteran aviators began to dwindle. The average Japanese naval pilot in 1941 had over 700 flight hours. By 1943, new replacements averaged under 200. Many went into combat after only 6 months of training. The Zero remained deadly in their hands, but less disciplined. Without the precision of experts like Saburo Sakai or Hiroyoshi Nishizawa, the aircraft's lack of protection turned every hit into a fatal one. Meanwhile, the Akutan Zero continued flying in test circuits over California. Engineers measured drag coefficients, recorded climb rates, and photographed every maneuver. The results guided the finishing touches on the Grumman F-6F Hellcat, then still in prototype form. The Hellcat's designers had never seen a Zero in person before Akutan. Now they had one in their hangar, and the data shaped the Hellcat into a machine purpose-built to destroy it. The Hellcat's massive Pratt & Whitney R2800 engine produced more than twice the horsepower of the Zero's Sakai Radial. It carried heavy armor-plating self-sealing fuel tanks and 650 caliber machine guns. It could dive past 400 miles per hour, well beyond the Zero's structural limits, and still pull out cleanly. By the time the Hellcat entered service in 1943, it embodied every lesson learned from that Alaskan marsh in simulated fights between the restored Zero and the first production Hellcat. The difference was brutal. The Zero could turn tighter, but only briefly. One burst from the Hellcat's guns shredded its unarmored fuselage. As a naval instructor observed dryly, "If you fight his fight, he wins. If you make him fight yours, he dies." The most profound revelation, however, wasn't technical. It was human. Every Allied pilot who trained against the captured Zero understood that its deadliness came at the cost of its pilot's life. A single bullet could turn that elegant machine into a torch. The Americans began to grasp a grim truth. Japanese superiority was built on sacrifice, not sustainability. In lectures at NAS North Island, instructors compared philosophies. The American approach treated pilots as irreplaceable assets. Machines existed to protect men. The Japanese approach treated pilots as expendable weapons. Machines existed to magnify their spirit. It was a contrast that mirrored the wider war-industrial pragmatism versus warrior idealism. The captured Zero had become more than a technological trophy. It was a mirror reflecting two civilizations in conflict. On one side stood the belief that courage and skill alone could triumph over material odds. On the other stood the conviction that victory belonged to systems factories, logistics, replacement chains. In that mirror, America saw its future, and Japan saw its doom. Winter, 1942. Across the Pacific, the war was turning, but slowly, painfully, and at a cost measured in thousands of lives. The intelligence drawn from the Akutan Zero had given the Allies their first real advantage in the air, but its full impact was still unfolding across the chain of islands and atolls stretching from Hawaii to the Solomon Sea. At the newly built airstrips on Guadalcanal, Marine pilots of the Cactus Air Force trained under a single doctrine written in bold at the top of every blackboard: never turn with a Zero. They drilled relentlessly in the new boom and zoom tactics inspired by the Akutan tests, diving from altitude, firing once and escaping before the enemy could react. These weren't elegant dogfights. They were calculated ambushes in the sky. The results were immediate. By early 1943, kill ratios that once favored the Japanese were reversing. Where early in the war, Zeros had claimed 12 American aircraft for every loss by late 1943, that ratio had flipped to nearly 1-4 in America's favor. The change was not just in technology, but in psychology. American pilots no longer feared the Zero, they studied it, anticipated it, exploited it. One pilot later wrote in his combat diary, "We stopped running. We stopped being afraid. Once you know his weaknesses, he bleeds like anyone else." The U.S. Navy's Bureau of Aeronautics distributed technical circulars titled "Characteristics of the Japanese Type Zero Fighter," summarizing Sanders' tests and adding field reports from new encounters. It became the most widely read document in naval aviation at the time. Every squadron briefed its new pilots with it before deployment. The key takeaway was simple, but revolutionary: speed kills, not turning. At North Island, test pilot Eddie Sanders continued to fly the recovered Zero, comparing it directly to the latest American aircraft, first the Grumman F-6F Hellcat, then the Chance Vought F-4U Corsair. The differences in philosophy were stark. The Zero remained graceful and responsive, but at high speeds the control stick became heavy, its roll rate collapsing. The Corsair, by contrast, was a brute fast stable and powerful enough to tear past 400 mph in level flight. In mock engagements, the Corsair always came out on top, its pilot safely armored behind bullet-resistant glass and steel plating. To the engineers watching from the ground, it was more than just a test. It was a visible metaphor for the shifting balance of power in the Pacific. Japan had built a thoroughbred racehorse, delicate and deadly, on a smooth track. America had built a bison slow to start unstoppable once it charged. Historians later describe this transition as the industrialization of air combat. In the first year of war, skill and individual daring had defined victory. By 1943, systems production and logistics did. A Rand Corporation post-war analysis titled Combat Performance Factors in the Pacific Air War noted that technological asymmetry in 1942 was replaced by production asymmetry in 1943. The United States was now outbuilding Japan nearly 10-to-1 in aircraft production. But that industrial momentum only mattered because the Akutan Zero had exposed how to fight effectively with those aircraft. It was intelligence turned into doctrine engineering, translated into victory. Meanwhile, on the Japanese side, reports began filtering back from the front. Commanders at Rabaul and Truk noticed something alarming. American fighters were surviving encounters that should have been fatal. They were diving away from combat faster than before, reappearing minutes later from above, striking and vanishing again. Zeros were being outmaneuvered not in turns, but in altitude. Pilots sent increasingly desperate messages to their superiors. Enemy fighters refuse dogfight. They strike and flee. Impossible to pursue. In Tokyo, Mitsubishi engineers and Imperial Navy officials convened emergency meetings. They understood what was happening. The Americans had learned the Zero's weaknesses. But Japan had no easy way to respond. The A6M5 variant introduced in 1943 added a small amount of armor and thicker wing skin to improve dive performance, but the modifications added weight without adding power. The result was a slower, less agile aircraft that lost the one advantage it once had. It was as one Japanese engineer later confessed, an aircraft designed for a war we were no longer fighting. At this same time, the Americans were refining the new Hellcat and Corsair in large numbers. Each incorporated lessons learned from the captured Zero, particularly in the balance between protection performance and range. The F6F Hellcat, with its enormous 2,000 horsepower Pratt & Whitney engine, could outclimb and outdive the Zero easily. It didn't need to turn tighter, it just needed to hit harder and survive longer. By late 1943, the Hellcat's debut over the Gilbert Islands proved decisive. Navy pilots claimed 300 Japanese aircraft in the first week of operations for minimal losses. The Hellcat's kill ratio would eventually exceed 19-to-1, one of the highest in aviation history. Analysts from the U.S. Naval Aviation Intelligence Center later credited part of that success directly to the Akutan Zero data. Beyond its tactical effects, the Zero's capture also reshaped American aircraft design philosophy. The engineers at Grumman Curtiss and North American began re-evaluating what made a fighter superior. Before Akutan, many still favored lightweight minimalist builds, sacrificing protection for agility, mirroring pre-war European ideals. After Akutan, the lesson was clear: a pilot's survival was more valuable than a few extra knots of speed. That realization had economic and cultural echoes far beyond aviation. The war economy of the United States could afford armor and redundancy. Japan's could not. It was the difference between two types of industrial societies, one that optimized for resilience and one that gambled everything on the brilliance of a few. Declassified post-war Japanese documents reveal how devastating this imbalance became. Mitsubishi engineers writing in late 1944 lamented, "We achieved lightness beyond what was thought possible. But this lightness is now a curse. Our fighters cannot protect their pilots, and our pilots cannot be replaced." By 1944, the average Japanese naval aviator had fewer than 150 flight hours before being sent into combat. In contrast, American pilots had over 400 with continuous training and rotation systems, ensuring experience spread across squadrons. The Akutan Zero had done more than expose the enemy's secrets. It had exposed the limits of Japan's entire war model. From the quiet marsh of an Alaskan island came a revelation that echoed through every Pacific sky. Victory was no longer about who flew the fastest. It was about who learned the fastest. And America was now learning at industrial speed. Spring 1943. Pacific skies once again roared with combat, but this time the hunters and hunted had changed places. For the first time since Pearl Harbor, American pilots were dictating the terms of engagement. The Akutan Zero, that silent wreck in the Alaskan marsh, had done what entire fleets of ships and armies of men could not. It had given the Allies the blueprint to dismantle Japan's most dangerous weapon, not just the Zero itself, but the myth of Japanese invincibility. At Henderson Field, Guadalcanal, pilots briefed under palm fronds and open skies. Chalkboards bore crude sketches of the Zero's silhouette, annotated with words that every Marine aviator knew by heart: ailerons freeze above 200 knots, engine cuts under -G, avoid turning fights. These weren't just tactical notes. They were survival scriptures. Major Joe Foss, Marine ace and Medal of Honor recipient, had already begun applying the lessons before the reports were even official. "I don't fight a Zero where he's strong," he told new pilots. "I fight him where he's weak, fast hard." And once, across the Pacific, these lessons became a playbook. Pilots who had once dreaded encountering Zeros now hunted them with predatory patience. They'd lure the enemy upward into thin air, forcing the lighter Zeros to stall first, then dive away in controlled bursts of speed that no Japanese engine could match. By early 1943, air superiority was no longer decided by instinct, but by data born from the wreckage at Akutan Island. American air combat had entered a new analytical era, one where aerodynamics, engineering, and psychology worked hand in hand. Even the U.S. Navy's design bureaus embraced this transformation. When Grumman engineers reviewed the Akutan Zero, they were struck not by its weaknesses, but by its genius, its precision weight optimization, the way every screw and bracket contributed to a singular goal maneuverability. Yet they also saw what Japan had sacrificed to achieve it. At a closed session in 1943, the Bureau of Aeronautics issued a statement that would shape American fighter design for the next decade. The ideal aircraft is not the one that performs best in a perfect fight. It is the one that brings its pilot home from an imperfect one. That principle guided the creation of the F-6F Hellcat F-4U Corsair, and later the P-51 Mustang machines designed not to mimic the Zero, but to outlast its philosophy. Meanwhile, back in Japan, the Imperial Navy wrestled with bitter irony. Engineers at Mitsubishi were already aware of the Zero's fragility, but they were trapped by doctrine and resources. The A6M5 improved. Zero added armor behind the pilot's seat and thicker skin around the wings. But these changes added nearly 600 pounds to the aircraft without a corresponding boost in engine power. The once superb maneuverability of the Zero degraded sharply. Test pilots complained that their beloved fighter had become sluggish, slow to climb, and prone to stalling at high altitude. The new armor provided minimal protection against 50 caliber rounds anyway. One burst from a Hellcat still shredded its airframe like paper. The Japanese had traded away their only true advantage, agility, and received nothing in return. It was an industrial tragedy unfolding in slow motion. The very strengths that had defined Japan's early air dominance, precision craftsmanship, minimal resource usage reliance on elite pilots, were now its undoing. The empire was locked into a production model that couldn't adapt to total war. A U.S. War Department study in 1944, Comparative Analysis of Aircraft Material Systems, described the Zero program bluntly. Japan optimized for victory in the first year. The United States optimized for victory in the fifth. The report noted that Japan's aviation industry lacked both the metallurgical diversity and mass manufacturing flexibility to pivot when the war shifted from skill to scale. Aluminum shortages had forced them to rely on inferior alloys. Pilot losses, once tolerable, now meant the irreversible decline of tactical expertise. In the skies above the Solomon Islands, these abstract truths took on flesh and fire. Lieutenant Commander Butch O'Hare led squadrons of Hellcats through formations of Zeros that once would have dominated the air. The new doctrine worked with ruthless precision: dive, shoot, climb, repeat. By mid-1943, the kill ratios spoke louder than any speech. In just one 6-month stretch, American fighters destroyed nearly 2,000 Japanese aircraft for the loss of fewer than 500 of their own. Yet the numbers told only part of the story. Beneath them lay a deeper shift, a transformation in morale. When the Zero first appeared in 1941, it was a symbol of terror. When its captured twin took to California skies in 1942, it became a symbol of revelation. By 1943, it was a symbol of hubris, a reminder that perfection, in one phase of war, guarantees nothing in the next. At the Rand Archives decades later, analysts would cite the Akutan episode as one of the most valuable unintentional intelligence coups in military history, on par with the breaking of the Enigma code. Not because it directly won battles, but because it reshaped thinking. The captured Zero had not only revealed technical data, it had revealed how Japan thought. The obsession with lightness and speed at all costs reflected a cultural belief that skill and spirit could overcome material disadvantage. This mindset, known as Seishin, had deep roots in the samurai ideal. It valued individual courage over collective efficiency, precision, craftsmanship over mass output. In contrast, America's design and production philosophy, pragmatic, modular, scalable, embodied a very different worldview that systems, not heroes, win wars. This was no longer just a clash of machines. It was a clash of civilizations, one fighting to prove the supremacy of human will, the other proving the supremacy of organized intelligence. The Akutan Zero had become the physical embodiment of that conflict. It showed that brilliance without resilience was doomed to collapse, and that even genius, when bound by dogma, becomes self-defeating. As 1943 closed, Allied commanders prepared to carry the air war into Japan's inner defenses. From the Aleutians to the Solomon Sea, every pilot, every plane, every plan now carried lessons learned from one pilot's fatal mistake and one nation's captured secret. From that lonely island in the fog, the tide of an empire had begun to turn. Summer 1943. Across the Pacific, the once invincible Zero was dying a slow, visible death. What had begun as a streak of triumph had become a study in desperation. The Akutan Zero's secrets had been fully absorbed into Allied tactics, engineering, and doctrine, and now the consequences were raining back down on Japan. At Rabaul, the nerve center of Japan's South Pacific Air Operations, returning pilots carried stories of impossible battles. They described American fighters diving from the sun, striking in seconds, then vanishing into the clouds. They complained that the enemy no longer fought fair, that dogfights were gone, replaced by brutal ambushes in vertical space. But war, by mid-1943, was no longer about fairness. It was about who had learned faster. The Zero, once a hunter, was now prey. When Lieutenant Commander Eddie Sanders concluded his series of test flights at North Island, he sent a final report to Washington. It contained an almost prophetic line: "The Zero's strength is in the skill of its pilot. Take that away and the aircraft becomes nothing." It was a statement that Japanese engineers could have written themselves had ideology not blinded them. By the time that report reached naval intelligence desks, Japan's elite airmen, the graduates of the Yokosuka and Tsukuba naval flight schools, were already vanishing into the sea, one sortie at a time. What replaced them were hastily trained conscripts men who had spent barely 150 hours in the air before being sent into combat. They climbed into Zeros, designed for masters, and died flying like novices. The contrast with the Americans was staggering. Thanks to data from the Akutan Zero, every U.S. Navy and Marine aviator now entered battle with a manual of the enemy's weaknesses, speed thresholds turning limits dive angles. No other war had ever seen such precise data-driven tactics, and the industrial machine supporting those pilots had grown monstrous in scale. By late 1943, American factories were producing nearly 6,000 aircraft a month, more than Japan could build in an entire year. Henry Kaiser's shipyards turned out escort carriers so quickly that new air groups could be trained and deployed before Japan could even replace a single squadron. It wasn't simply manufacturing. It was momentum, a rolling wave of steel, aluminum, and intellect that no empire could stop. Still, Japan tried. In Tokyo, the Navy Technical Department gathered in somber sessions under the watchful eyes of bureaucrats who refused to accept defeat. Mitsubishi's engineers proposed the A7M Reppu, a successor to the Zero that would finally combine armor with power. Nakajima engineers countered with their Kai-84 Hayate, a land-based fighter built for speed and climb rate. Both designs were ambitious, but both suffered from the same fatal constraint. Japan no longer had the industrial resources to mass-produce them. The factories that once turned out engines and alloys were now bombed, blockaded, or starving for materials. The phenolic resins and alloys that gave the Zero its lightness were gone. Skilled machinists had been drafted into the army. Balsa and spruce were replaced by heavier pine and plywood. By mid-1944, the once precise assembly lines of Mitsubishi and Nakajima resembled desperate workshops. Even the glue, the literal adhesive holding aircraft together, became a symbol of decline. In reports unearthed after the war, engineers admitted that shortages of proper bonding agents led to structural failures in late-model Zeros. Wings delaminated in humidity, fuselages warped in tropical climates. In contrast, the United States had perfected an industrial ecosystem. Grumman's Ironworks on Long Island ran 24 hours a day. Douglas and Vought collaborated with Ford and General Motors, transforming automobile factories into aviation hubs. Allied production was not only vast, it was integrated, self-sustaining, and adaptive. The same efficiency that built the F-6F Hellcat also produced Liberty ships' radar systems and fuel logistics that kept entire fleets at sea indefinitely. Japan, once confident in the samurai's fighting spirit, now faced the cold mathematics of total war. Courage could not replace oil. Skill could not replace steel. American engineers, meanwhile, continued studying the Akutan Zero long after the first tests ended. They dissected its frame not only to learn how to fight it, but to understand how it thought. The Zero's simplicity, they realized, was its genius. It proved that performance came not from abundance, but from focus, from removing every unnecessary element. That lesson would echo decades later in aircraft, like the F-86 Sabre, and even the early jet age. But the Americans also recognized something deeper. Performance divorced from survivability was suicide. The Zero represented a weapon built on an assumption of short war and infinite bravery, a beautiful machine conceived in denial of reality. At the Rand Archives in 1951, an analyst summarized it bluntly: the Zero was perfect for a war Japan could never win. Throughout 1944, Allied pilots reaped the results. At the Battle of the Philippine Sea, remembered forever, as the Great Marianas Turkey Shoot. Japanese air power collapsed in a single day. Over 500 Japanese aircraft were destroyed. Barely 100 American fighters were lost. The Hellcats and Corsairs tore through Zeros with overwhelming speed and armor, their pilots unflinching behind bullet-resistant glass. One U.S. aviator, Lieutenant Alexander Vratziu, downed 6 Zeros in 8 minutes. His gun camera footage showed the Zero's fatal flaw in motion. Each hit ignited fuel lines instantly, the aircraft blooming into fireballs before even beginning to spin away. Those infernos bright against the Pacific sky marked not just the end of a machine, but the end of an idea. By late 1944, Japan's air strategy had descended into despair. With no hope of industrial parity and no veteran pilots left to fly the Zero effectively, the Imperial Navy began converting its remaining fighters into kamikaze aircraft. The same A6M model that had terrorized the Pacific in 1941 was now stripped of guns and loaded with explosives, its pilots ordered to crash into American ships. The transformation was tragic and symbolic. The Zero, once the expression of aerodynamic grace, had become a suicide weapon. The design that had embodied Japan's technological pride was now a delivery system for hopelessness, and the Americans who had studied Koga's captured Zero in San Diego understood the irony better than anyone. The aircraft that once symbolized dominance now symbolized death, and its fall had begun the moment its secrets were exposed in the fog of Alaska. From that day forward, every Zero destroyed carried the ghost of one that didn't burn, the one that taught the world how to beat it. Early 1944, the Pacific sky, once a domain of daring and elegance, had become an industrial battlefield. Where dogfights were once contests of skill, they were now equations of speed, altitude, and production. And at the heart of that transformation lay one unlikely teacher, a wrecked aircraft salvaged from a lonely Alaskan marsh nearly 2 years before. The Akutan Zero had begun as a technical curiosity, but by 1944, its lessons had become an unspoken gospel of American air doctrine. Every U.S. Navy and Marine pilot knew the mantra, boom, zoom, climb, survive. It was doctrine not born of theory, but of necessity and of intelligence derived from the single most valuable captured aircraft of the Pacific War. In Washington, military analysts studied how the Zero's weaknesses mirrored Japan's larger wartime vulnerabilities. The parallels were uncanny. Just as the Zero was fast but fragile, Japan's empire had expanded rapidly, but without durability. Just as the Zero sacrificed armor for reach, Japan had overextended across the Pacific without the supply infrastructure to sustain it. And just as the Zero depended on the irreplaceable skill of a few elite pilots, Japan's war effort depended on a finite cadre of experts, craftsmen, tacticians, and commanders who could not be replaced as the war dragged on. The Americans had understood the equation and inverted it. They built machines and a war economy designed to absorb losses and keep improving. Every destroyed Wildcat or Hellcat was a data point. Every returning pilot, a living archive of tactical learning. The system learned faster than any individual ever could. This contrast, individual brilliance versus systemic resilience, became the defining pattern of the Pacific Air War. At the Bureau of Aeronautics, a team led by Commander Frederick Trapnell, one of the Navy's most respected test pilots, conducted a detailed post-mortem comparison between the Akutan Zero and the Hellcat. Their conclusion was striking. The Zero is the better aircraft for a single engagement. The Hellcat is the better aircraft for a war. That sentence encapsulated the entire conflict. Japan had designed for perfection. America had designed for longevity. As 1944 progressed, the air war grew increasingly one-sided. Over the Marianas, the Philippines, and Formosa, swarms of Hellcats, Corsairs, and P-38 Lightnings dominated the sky. The once feared Zero, now outclassed and obsolete, became a tragic anachronism. Pilots still revered its agility, but they also knew its curse. It could no longer keep up, and every hit meant death. Captain David McCampbell, who would become America's top Navy ace with 34 aerial victories, described his first engagement with a 0 over the Philippines. He turned beautifully, but I could see his mistake. He stayed slow. I stayed fast. I dove through him like a hammer through glass. The same philosophy applied across the Pacific: speed and energy over elegance and maneuver. Every American victory in the sky was now also a victory of adaptation. In the Imperial Japanese Navy, the reality was unbearable. Reports from the field grew grim. The once proud carrier divisions which had unleashed the storm on Pearl Harbor were now shadows of their former selves. After the Battle of the Philippine Sea, the Japanese Navy had fewer than 100 trained carrier pilots left. For every experienced airman lost his replacement, brought half the training, and none of the confidence. At Mitsubishi's plant in Nagoya, chief designer Jiro Horikoshi, the man who had given life to the Zero, watched the dream crumble. His engineers tried desperately to upgrade the aircraft: larger engines, thicker armor, even experiments with wooden components to save metal, but it was too late. The Zero's brilliance had been built for a short, decisive war, not an industrial war of years. Horikoshi later wrote in his memoirs, "We built an aircraft for samurai. The Americans built one for soldiers." And the soldier outlasted the samurai. By 1944, that contrast was visible everywhere. In the skies above, Saipan and Guam Zeros fought not as predators, but as relics hurled into hopeless defense. Many were stripped of guns and packed with explosives, repurposed for the desperate kamikaze missions that began later that year. Each suicide flight was a grim acknowledgement that Japan's air power, once its proudest weapon, had reached the end of its evolution. Back in the United States, the Akutan Zero still sat at Nass North Island, repaired and repainted in U.S. Navy blue-gray markings used to train young pilots before deployment. Every man who climbed into the cockpit of a new Hellcat or Corsair, had watched it fly, had seen firsthand how the enemy moved, rolled, and failed. It had become a living textbook, a reminder that even the mightiest machine could be undone by understanding. The war correspondent Fletcher Pratt, reporting for the Saturday Evening Post in late 1944, described watching the captured Zero taxi under guard in California. "The thing looks delicate, almost fragile, a dragonfly in a world of steel hawks. You can't help but feel respect for its grace and pity for its purpose." Historians would later note that this single aircraft, salvaged from the mud and flown half a world away, had arguably saved more Allied lives than any other captured weapon in World War II. The tactics it inspired reduced pilot deaths by the thousands. Its insights shaped the design of aircraft that would dominate the final years of the conflict and lay the groundwork for jet-age combat philosophy. Yet its impact reached even deeper into the realm of culture and strategy. The Akutan Zero forced American military planners to rethink how they understood their enemies, not as abstract threats, but as products of culture, economy, and ideology. RAND analysts studying the aircraft's story after the war coined a term for it: cultural engineering failure. They argued that Japan's defeat stemmed not only from material inferiority, but from a refusal to align technology with strategic reality. In other words, Japan had built an aircraft that reflected who they believed they were: fearless, precise, unstoppable, instead of who they actually were, an island nation fighting a continental empire with finite resources. The Americans, by contrast, had built machines that reflected their truth: vast, mechanical, impersonal, but enduring. The Hellcat was not beautiful, but it was inevitable. By late 1944, this philosophical divide was measured not in theory, but in bodies. Over the Philippines and Leyte Gulf, American radar screens tracked wave after wave of kamikazes, many of them former Zeros diving toward U.S. carriers. The same graceful design that had once symbolized Japan's pride now carried its sons to their deaths, and far from the front lines in a hangar bathed in California sunlight, the Akutan Zero rested in silence, its propeller scarred, its once bright markings dulled by time, a relic of the day when knowledge turned the tide of war. In that stillness lay a quiet irony Japan had lost, not because the Zero was weak, but because America had understood it. The war was entering its final devastating year. The skies that once belonged to Japan would soon be filled with new engines, heavier, faster, louder, bringing with them a storm that even the legendary Zero could not outrun. Winter 1944. The war in the Pacific had entered its terminal phase, and in the dim light of Japan's remaining airfields, the Zero still waited on the tarmac, like a ghost of a vanished age. Its slender wings, once symbols of dominance, now looked fragile beside the hulking shapes of American B-29s cruising overhead at altitudes it could barely reach. The wooden wonder from Akutan, stripped of its myth, had transformed from terror to teacher its captured airframe now flying in California skies. Its lessons echoed across every squadron briefing from the Solomons to the Philippines. But the full meaning of the Akutan Zero extended beyond tactics and hardware. It had revealed a truth about warfare itself, that technology stripped of context was only half a weapon. The rest came from the systems that built it, the doctrines that guided it, and the beliefs that shaped it. And those beliefs were now consuming Japan from within. By late 1944, the Zero's design bureau at Mitsubishi was effectively operating in crisis mode. Chief designer Jiro Horikoshi, the man whose dream had lifted the Zero into history, had grown visibly older, worn by fatigue and frustration. The once celebrated aircraft was now obsolete against the Hellcat Corsair and Mustang. New prototypes like the A7M Repu and J2M Raiden struggled to reach production amid shortages of fuel aluminum and skilled labor. Allied bombing raids had crippled Japan's supply chains, scattering engineers into mountain tunnels and improvised factories. Horikoshi would later write in words that carried both pride and regret. We had created beauty and speed, but not endurance. Our wings were strong only as long as the spirit of our pilots endured. When they fell, so did our aircraft. In the same months across the Pacific, that same spirit transformed into desperation, was taking a new form. The first organized kamikaze units were launched from Luzon and Formosa, many of them flying modified A6M Zeros. Their fuel loads were cut in half to make room for 250-kilogram bombs bolted beneath the fuselage. Their pilots, some barely 20 years old, were told their sacrifice would save the nation. When the first kamikaze struck USS St. Lo during the Battle of Leyte Gulf in October 1944, the explosion tore through the flight deck and sank the carrier. American sailors, stunned by the attack, struggled to comprehend the logic behind it. Yet for the Japanese command, it made a kind of grim sense. If the Zero could no longer defeat the enemy in combat, it would at least serve as a weapon of despair. In that shift from fighter to suicide weapon, the Zero completed its tragic arc from a triumph of engineering to a monument of futility. The same aircraft that had once embodied Japan's technological pride now symbolized its moral exhaustion. Back in California, the Akutan Zero remained at Nass North Island, still under armed guard. By late 1944, it had been repainted in U.S. Navy colors and was used as a demonstration aircraft for new pilots. Every class watched it taxi out under the Pacific sun. Instructors pointed to its narrow landing gear, its delicate skin, its unarmored cockpit, and reminded their students, "This is what happens when you build for speed and glory, instead of survival and victory." Young pilots listened in silence. For many, it was their first close look at the enemy they would soon face over the Philippines or Iwo Jima. They ran their hands over its riveted frame, surprised at how thin it felt, like a soda can, one recalled. In that hangar, Thousands of miles from the front, they touched history and understood it. The test flights continued until early 1945. By then, its purpose had been fulfilled. The Zero that once changed the war now served as a relic of the lessons it had taught, that technological brilliance cannot compensate for strategic blindness, and that courage cannot replace planning. As the Allies advanced, those lessons were proven again and again. At Iwo Jima, Marines watched as kamikaze pilots dove their aging Zeros straight into American ships, sometimes hitting, often missing, always dying. At Okinawa, hundreds followed, turning the sky into a graveyard of smoke trails. Each explosion was a reminder of the Zero's fatal philosophy, the perfection of performance pursued at the cost of survival. Meanwhile, in American factories, assembly lines continued to hum. The Hellcat and Corsair, both direct beneficiaries of Akutan's insights, were being built faster than Japan could shoot them down. For every Zero that rose from a coastal airfield, 5 Hellcats took off from U.S. carriers. The mathematics of war had become merciless. The captured Zero's influence stretched even further than the Pacific. British engineers studying its design at Farnborough reported findings to the Air Ministry, which incorporated elements of its wing geometry into post-war jet prototypes. American designers noted the benefits of its low drag coefficient and seamless fuselage joints principles that would later reappear in the jet-powered F-86 Sabre. Ironically, the aircraft that once symbolized Japan's isolationist ingenuity helped shape the technology that would define the Western world's air dominance for decades to come. By the spring of 1945, the Akutan Zero was no longer an aircraft of war, but an artifact of enlightenment. Its existence had rewritten the rules of aerial combat, its flaws had informed the creation of new legends, and its capture had turned ignorance into mastery. And yet its story was not over. In February 1945, after thousands of flight hours and dozens of demonstration sorties, tragedy struck. During a routine taxi test at NAS North Island, a Curtiss SB-2C Helldiver collided with the Zero on the ground, crushing its delicate fuselage beyond repair. The aircraft that had changed the Pacific War was finally destroyed, not by gunfire or bombs, but by accident on friendly soil. The remains were quietly scrapped. No official ceremony marked its end. The war moved on, consuming attention and resources, leaving the Akutan Zero to slip into legend. But the legacy it left behind, the doctrines it inspired, the technologies it influenced, and the philosophy it challenged would outlive the men who had first seen its red circles through Alaskan fog. In the end, perhaps that was fitting. The Zero had taught the world its final lesson, that victory does not belong to the swift or the fearless, but to those who learn. And no aircraft in history ever taught its enemies more. Spring 1945. Tokyo burned. The skies that once roared with the pride of the Imperial Navy's Zero fighters now trembled under the endless drone of American B-29s. Incendiaries rained down over the wooden city, the same kind of lightweight material that once defined Japan's most famous aircraft. In every sense, the Zero's philosophy, lightness over endurance, had come home to haunt the empire that created it. In the ruins of Mitsubishi's Nagoya plant, Jiro Horikoshi stood watching the remains of his factory smolder. His engineers worked by candlelight, now drawing blueprints in underground tunnels as air raid sirens wailed above. He still believed in the beauty of his creation, but beauty no longer had a place in war. The Zero had become a relic of a world that no longer existed, a world where skill and craftsmanship could outweigh numbers and steel. Across the Pacific, the Americans were building not just aircraft but systems. A single Hellcat required nearly 200,000 parts, and everyone could be replaced in days. A damaged Zero, by contrast, was a death sentence for both machine and pilot. Where Japan relied on art, America relied on arithmetic. The contrast could not have been clearer. In California, the remains of the Akutan Zero, now a wreck once more, were studied one final time before being quietly scrapped. Engineers at Grumman and Vought had already extracted every lesson it could offer. The reports compiled from its tests were now standard reading at U.S. Navy training schools. They included graphs of roll stiffness notes on carburetor failures under -G diagrams, showing the weak points in its fuel system, all hard-won knowledge that had been purchased by a single pilot's fatal mistake in an Alaskan marsh. That knowledge had rewritten air combat. The boom and zoom doctrine was now gospel. American pilots no longer thought in terms of turns and angles. They thought in energy states and momentum. Battles became vertical dives, climbs, slashing passes, where the Zero's delicate frame and slow roll response doomed it every time. The irony was painful. The Zero's own elegance had made it obsolete. At the same time, the cultural foundations of Japan's war effort were collapsing. The Bushido code that glorified self-sacrifice had turned into a death spiral. Newspapers in Tokyo printed euphemisms for kamikaze missions, special attacks, one-way flights. But the truth was unavoidable. Japan's best pilots were now its most expendable weapons. In one letter recovered after the war, a kamikaze trainee wrote, "They say the Zero is light enough to dance with the wind. I only hope it dances one last time before it burns." The tragedy of that line mirrors the tragedy of the aircraft itself. By the summer of 1945, Japan's air defense system was collapsing completely. American P-51 Mustangs and F-4U Corsairs swept the skies at will, escorting bombers over Japan's homeland. The few Zeros that rose to challenge them were destroyed within minutes. The pilots who once claimed impossible kill ratios now fought with obsolete weapons against an enemy that had turned science and scale into instruments of inevitability. On July 24, 1945, the last operational Zero units were stationed in Kyushu. Fuel shortages limited them to one-hour patrols. Some aircraft had their aluminum skins patched with wood. Others used reclaimed engines from wrecked planes. They flew not for victory, but for symbolism, for the idea that Japan could still resist, even as the world closed in. 2 weeks later, the world ended in light. Hiroshima, Nagasaki, the Zero, that once invincible warrior of the skies, would never fly again. After the surrender, American technical missions arrived to inspect what remained of Japan's aviation industry. They found dozens of Zeros grounded and decaying in hangars, their thin aluminum skin pitted with corrosion. To the engineers who examined them, they were paradoxes, masterpieces of craftsmanship bound by fatal ideology. One officer remarked, "You can feel the intelligence in every joint, and the ignorance in every assumption." The Akutan Zero, though gone, had already answered the question those men were asking. How could a nation so skilled in design fail so utterly in war? The answer lay not in engineering, but in philosophy. The Zero had been built on faith in the pilot's courage, faith in the short war, faith that speed and precision would triumph over material power. But faith cannot outfly fuel, and courage cannot resist physics. It was the Akutan discovery that had exposed the fatal contradiction of that faith. By capturing and dissecting one perfect machine, America had understood an entire nation's mindset and learned how to defeat it. In 1946, the U.S. Navy quietly declassified the full Akutan report. Historians would later call it the Rosetta Stone of the Pacific Air War. Inside were the raw flight data control diagrams and performance charts that had circulated among every Allied squadron. It documented not only how the Zero flew, but how it thought. That report became a foundational text for post-war aircraft design. Its analysis of lightweight structures and aerodynamic efficiency influenced not only fighters like the F-8F Bearcat and P-80 Shooting Star, but even civilian aerodynamics research at NASA's predecessor NACA. The The Zero had become ironically a teacher in peace as it had been in war. Meanwhile, in post-war Japan, Horikoshi and his surviving engineers faced interrogation and then obscurity. When the American occupation lifted restrictions, they returned quietly to civil aviation. Horikoshi later helped design Japan's first post-war airliner, the YS-11, a sturdy utilitarian plane built not for glory, but for endurance. Perhaps in that design, he was finally at peace with the lesson the Akutan Zero had taught him: perfection, without pragmatism, is ruin. Today the Zero exists mostly in museums and memories. Restored examples gleam under soft lights, their paint immaculate, their forms still elegant. Visitors stand in silence, some in admiration, others in mourning. To engineers, it is a masterpiece of aerodynamic purity. To historians, it is a warning written in aluminum and fire, because in the end, the Zero was never defeated by the Hellcat or the Mustang alone. It was defeated by time, by the passage from a world of warriors to a world of industry, from instinct to information. When Albert Knack first saw those red circles gleaming through Alaskan fog in 1942, he could not have known he was looking at the moment the Pacific War would turn. That wreck in the marsh was not just an aircraft. It was the hinge of an era where myth gave way to method and emotion gave way to understanding. The Zero had soared on the wings of faith. The Akutan Zero had fallen on the weight of fact, and in that fall, the world learned what war in the modern age would always demand: not passion, but precision. Autumn, 1945. Japan lay silent. The war that had begun with the thundering of engines over Pearl Harbor ended beneath a mushroom cloud. The same air that once lifted Zeros into glory now carried the acrid scent of ash and surrender. In the ruins of Tokyo, among twisted hangars and scorched airstrips, the skeletons of Zeros lay like the bones of extinct birds, fragile, perfect, and utterly still. Mechanics who had once polished their fuselages now stood idle, their uniforms threadbare, their tools rusting in puddles of rainwater. A few aircraft remained intact, stripped of insignia, and awaiting the arrival of American inspection teams. For the first time, the rising sun markings on their wings meant nothing. Half a world away in a quiet warehouse in San Diego, the remains of the Akutan Zero rested in crates, its once celebrated frame reduced to labeled fragments, fuselage sections, propeller blades, and engine mounts. To the U.S. Navy, the aircraft's mission was over. Its lessons had already rewritten the Pacific Air War, reshaped aircraft design, and exposed a nation's fatal ideology. But to the engineers and test pilots who had worked with it, there was something sacred about those pieces. They had learned more from that single wreck than from 1,000 battles. For historians, the story of the Akutan Zero would come to symbolize the power of information in modern warfare. In earlier centuries, victory depended on courage and numbers. In the industrial age, it depended on knowledge. The capture of one enemy aircraft, studied with precision and shared across a continent, had done more to change the balance of power than any bomb or bullet, and yet the Zero's legacy did not end in bitterness. In post-war Japan, the aircraft that had once embodied imperial ambition became a mirror for national introspection. Its designer, Jiro Horikoshi, returned to civilian life under the occupation. Forbidden to build military planes, he began designing components for peaceful aviation. His reflections in later years carried a tone of quiet remorse. We wanted to create something beautiful. We succeeded. But beauty alone is never enough. His words capture what the Akutan Zero had proven: that perfection without purpose is tragedy. In the United States, the lessons of Akutan continued to ripple outward. Engineers at Grumman North American and Douglas used its aerodynamic data to refine post-war jet fighters. Test pilot Fred Trapnell, who had supervised many of the Zero's trials, later joined the Jet Aircraft Division and directly applied its findings to stability control research. The Zero's legacy became part of a lineage that extended from propeller to jet, from the Hellcat to the Sabre, from the noise of piston engines to the scream of afterburners. Every innovation carried a whisper of that Alaskan discovery, a reminder that knowledge once captured could not be undone. For the men who flew the Zero in war, however, the memories were more complicated. Surviving Japanese pilots interviewed after 1945 often spoke not with shame, but with sorrow. Many described their aircraft as an extension of themselves, light alive, almost sentient. One veteran recalled, "It responded like a thought, but it punished every mistake. You had to fly it perfectly because it forgave nothing." That duality, brilliance and fragility, grace and doom, defines the Zero's legend to this day. It was both the best and the worst of its kind, a marvel of design born from an impossible doctrine. In American museums, the Zero now sits beside the Hellcat and Corsair, the very aircraft that destroyed it. Visitors who walk between them often feel the weight of that juxtaposition. On one side, the machine of efficiency and endurance. On the other, the machine of passion and sacrifice. Between them lies the story of the 20th century, the transformation of war from a contest of men into a contest of systems. But there is a deeper lesson that transcends military history. The Akutan Zero revealed how culture shapes technology, how belief and identity can become encoded in metal. Japan's engineers built an aircraft that reflected the soul of their nation, disciplined, daring, fatalistic. America built machines that reflected its own values, pragmatic, resource-rich, relentlessly iterative. Both were true to their makers. Only one could survive a long war. In this, the Akutan Zero is more than a story about airplanes. It is a parable about the human condition, about how brilliance untempered by humility leads to ruin. Modern military analysts still study its capture as one of the most consequential intelligence finds in aviation history. The Rand Corporation compared it to the later Soviet MiG-15 defection during the Korean War and the MiG-25 Foxbat defection in 1976. Each event changed global air strategy, but Akutan was first. It proved that understanding the enemy's engineering could be as powerful as defeating his army. Even decades later, aviation engineers find themselves inspired by its elegance. Its lines, the sweep of the wing root, the slender nose, the smooth taper of the tail, are studied not as instruments of death, but as works of art. Designers of modern ultralight and aerobatic planes still reference its balance and simplicity. What once served destruction now informs creation. At memorials across Japan, former pilots and their families still gather every summer to honor the men who flew the Zero. They do not glorify the war. They mourn what it consumed, a generation of talent and spirit, lost to arrogance and ambition. At the Chiron Peace Museum, visitors stand before the preserved letters of kamikaze pilots who once flew Zeros, their handwriting still neat and careful. Many of them mention not hatred, but gratitude to the aircraft that carried them to their fate and sorrow for the world that demanded it. Perhaps that is the most human truth the Akutan Zero left behind. Machines, after all, are only reflections of their makers. The Zero did not fail Japan. Japan failed the Zero by asking it to bear the weight of a war it could never win. As the world entered the jet age, the wreckage of that once terrifying fighter faded into history. Yet, in the silence of museums and archives, the echo of its engine remains a reminder that even the most beautiful design can be undone by the philosophy behind it. 80 years later, the Akutan Zero's legacy endures not in the roar of flight, but in the quiet hum of understanding. Every engineer who studies it, every historian who writes about it, touches a moment when knowledge turned the tide of war. And somewhere in that Alaskan marsh, beneath the fog and grass, the ghost of Tadayoshi Koga still lies within the silence, the young pilot who never knew that his final flight would save thousands of lives and teach the world the cost of brilliance without balance.